Spherical shells, otherwise known as ball shells, are by far the most commonly used fireworks worldwide. This cross-section of a 3-inch shell is approximately the size of the largest shells that would be available to a consumer in the United States. Comparably, these two 6-inch shells are about the size you might see in a professional fireworks display. To fire a ball shell, the shell is first lowered into a fiberglass pipe known as a mortar. The fuse is hung outside the top of the pipe for ignition. You might have noticed that the fuse that is attached to this shell might look a little different than the green visco you're used to seeing. This paper-coated fuse is called quick match and contains several strands of black powder-coated string. When quick match is ignited, it burns at a rate of about 100 feet per second. This makes it very useful for professional fireworks displays where you want the shell to fire as soon as it is ignited. It would, however, be very dangerous for consumers as they may ignite the fuse not knowing it would fire instantly. That is why all consumer fireworks have this slower burning green visco fuse instead. A fireworks shell operates very much like a cannonball. After it has been lowered into a fiberglass mortar, the fuse is lit and the flame travels down the fuse and into a charge of black powder which is contained on the outside of the shell right in here. When this charge is ignited, it simultaneously fires the shell from the mortar as well as igniting a time fuse, which is a delay between when the shell is fired and when it explodes in the air. The fuse that is ignited as the shell fires from the mortar is made specifically for this purpose. It burns in such a way that the flame travels through the core of the fuse without igniting the paper on the outside. This fuse does burn rather slowly, and for a shell of this size you only want a piece about this long. As you can see in this model, the fuse is extended to be directly in the center of the shell with a 1/4-inch cardboard tube. It is made so because if the ignition point were not directly in the center of the shell, it would burn unevenly and the stars would be thrown in a non-symmetrical break. In order to ensure that plenty of fire from the fuse leaves the end of the tube, the empty portions are filled with black powder-coated string, similar to the quick match fuse. Now once the black powder lift charge has fired the shell into the sky and this time fuse has burned all the way through into the center of the shell, it will ignite the break charge. The break charge is all of this salt and pepper colored material that you can see filling the center of the shell, as well as this middle ring right here. The most common break charge used in fireworks is black powder coated onto rice hulls. Rice hulls are literally the husk that comes off of rice when it is harvested. Black powder coated onto rice hulls is much lighter than plain granulated black powder. Therefore, shells using black powder-coated rice hulls will be significantly lighter than shells that are packed to the brim with solid black powder. This also saves on resources and allows less black powder to be used in each shell. When the break charge is ignited, it simultaneously forces the shell to explode, as well as igniting many spheres of pyrotechnic composition. The black spheres, which are in 2 consecutive rings inside of this shell, are known as stars. They are what create the visual effect you see in the sky when a firework explodes. By varying the compositions that these stars are made of, they can be made to burn in any of the colors that you see in fireworks. In this particular shell, you can see that the stars have been shaped into 2 different rings. This is called an inner and an outer petal. The effect that this would present in the sky would be one sphere inside of another. In most shells, there is only one single petal, and so the inner ring of stars is disregarded. This smaller 3-inch shell would be a demonstration of a single petal. I hope this video was very educational. Please comment, subscribe, and pass this video along to others.